Welcome to this explainer. Okay, if you live in Middle Tennessee, you already know your HVAC system isn't just cooling your home, it's fighting a daily, grueling war. Today, we're going to unpack exactly why home heating and cooling systems tend to fail under the intense environmental pressures we see around here. And more importantly, we'll cover how you can protect your equipment and, let's be real, your wallet.
So, here's our roadmap for today. We'll start with Tennessee's brutal climate test, move into the anatomy of a breakdown, outline the three-step service process, cover some crucial rules of thumb, and finish up with the gold standard of installation. Section 1. Tennessee's brutal climate test. To really get why your system breaks down, we first have to understand the extreme battlefield it's operating on right here in Spring Hill. Think about what your system actually goes through. On one side, we've got those summers pushing 90+ degrees with that crushing humidity, right? It literally forces your air conditioner to run nonstop. Then flip to the other side. Winter brings freezing nights and brutal ice storms. This rapid thermal cycling back and forth puts an immense, almost unbelievable amount of mechanical stress on your unit all year round.
But honestly, the weather is only half the battle. We've also got hidden hyperlocal hazards. Take the shifting red clay soil around Maury County. It physically pulls ductwork apart as foundations settle, tossing the high dust loads from agriculture, the constant construction, and those undersized builder-grade ducts from recent housing booms, and your system is practically choking while trying to run a marathon.
Moving on to Section 2, the anatomy of an HVAC breakdown. Now that we know exactly who the enemy is, let's look at how this pressure creates very specific, totally predictable component failures inside your unit. First up are capacitors and contactors. These are the electrical components that store the charge to actually start your motors and switch the power. The relentless summer heat around here literally thries these starting components faster than anything else. It's usually the culprit when your AC just flat out refuses to wake up. Next, we've got a seemingly paradoxical problem for the middle of a hot summer: frozen evaporator coils. This happens when the coils literally ice over. Why? Usually because of low refrigerant from a tiny leak or restricted airflow from dust-clogged filters. And here's the kicker. This ice causes your compressor to work exponentially harder, driving up your utility bills and risking permanent, massive damage. Then, in the winter, we're dealing with cracked heat exchangers. The extreme expansion and contraction from that winter thermal cycling can actually fracture the metal right inside your gas furnace. And this is an absolutely crucial point. A crack here allows deadly carbon monoxide to enter your home's air supply. Seriously, it's a major life safety hazard you simply cannot afford to ignore. All right, Section 3, the three-step service process. When these inevitable breakdowns do happen, you really need to know what professional, transparent repair should actually look like. Look, a proper fix isn't just a guy swapping parts and crossing his fingers. It requires a specific 1, 2, 3-phase flow. Step 1 is system diagnosis, testing the actual pressures and airflow to find the root cause, not just treating the symptom. Step 2 is repair execution, using stocked parts and manufacturer specs so you aren't waiting days. And step 3, the one that's often skipped, is operation verification. That means testing the final temps and electrical draw. This guarantees we aren't just guessing, but diagnosing, fixing, and proving the system works before calling it a day. Okay, Section 4, crucial HVAC rules of thumb. I'm going to empower you with some absolute insider secrets right now to protect your wallet the next time you're facing a repair. $5,000. This exact number is the key to knowing exactly when it's time to stop repairing an old, failing unit, cut your losses, and start fresh. Here's how it works. It's known in the industry as the $5,000 rule. You just multiply your system's age by the estimated repair cost. If the result is over $5,000, replace it. Under, repair it. So say you've got a 12-year-old system facing a $450 repair bill. 12 times $450 is $5,400. Boom. That means a replacement is without a doubt your smartest long-term financial move. It takes all the emotion out of the decision and gives you a solid mathematical baseline. Now here's another incredibly simple yet vital number for you: 3. This is a number that could literally save your system's most expensive component. This is the 3-minute rule. It's the mandatory wait time you have to give your air conditioner after it shuts off before restarting it. Why? Well, it allows the highly pressurized refrigerant to equalize safely within the system. Starting it up too soon, like when you impatiently flick the thermostat down on a sweltering day, forces the compressor to work against completely unbalanced high and low pressures. That one simple, everyday mistake can cause an instant, insanely expensive compressor failure. Just remember, always wait 3 minutes. Finally, we arrive at Section 5, the gold standard of installation. If you do end up having to replace your system, here are the exact building codes and certifications you have to demand from any contractor. These are not just polite industry suggestions. They are the absolute gold standard. You've got Manual J, which calculates the precise heat load and equipment sizing for your specific house. Manual D dictates proper ductwork design and actual airflow. And EPA Section 608, that is a legally required certification for safe refrigerant handling. Never let someone just guess your system size based on square footage. Demanding these specific standards ensures your system runs safely and efficiently. Especially in Spring Hill's super humid climate, proper sizing and perfectly sealed ductwork directly dictate whether your system will actually reach its typical 12 to 18-year lifespan. Honestly, an undersized system fighting leaky ductwork in a humid red clay crawl space, it's just going to burn itself out way faster than it ever should. So, let's wrap this up. I want to leave you with this final, vital question. Is your HVAC system a ticking time bomb, or is it properly armed to win the Tennessee climate battle? Seriously, take a look at your own system's maintenance history today. Because trust me, the absolute best time to prepare for that brutal heat wave or that freezing ice storm is right now, long before your thermostat goes completely blank. Thanks for joining me on this explainer, and hey, stay comfortable out there.